Okay, let's look at rules for naming organic compounds. We have the first one, identify the parent chain. Actually, the parent chain is the chain with the longest continuous carbon, okay? Now, the second one is identify the principal substituent group and functional group. Then the third one, number the carbon atoms in the parent chain from the end, which will give the lowest number to the substituent group. But if there is a functional group in the compound, the functional group is given the smallest possible number. Then number 4, if a particular substituent group is present more than once, the number of the substituent group is indicated by a prefix di if it is 2, tri if it is 3, tetra if it is 4, etc. attached to it. Okay, the fifth one, if there is more than one type of substituent in a molecule, the substituents are named according to the alphabetical order, but where there are mixed substituents, the inorganic are named first. Okay, we have an example here. Give the name of the following compound. So we want to give the name of this compound, and according to the rule we have here, the rule says we should identify the parent chain first. So let's identify the parent chain here. Now the parent chain is the chain with the longest continuous carbon. So let's identify it. Let's count this one. 1, 2, 3, 4, 5, 6, 7. We have 7 atoms here. And let's count this chain. 1, 2, 3, 4, 5. This chain has 5 carbon atoms. So our parent chain is going to be this one. Okay, and this is going to be heptane. So the compound is heptane. Now the second step says identify the principal substituent group and functional group. Okay, now in this compound we don't have a particular functional group, but we have substituent group here. We have chlorine, and chlorine is 2. We have 2 atoms of chlorine, and we also have methyl. Now since we take this chain as our parent chain, it means that this methyl here is now a substituent group. Now the third one, number the carbon atoms in the parent chain from the end, which will give the lowest number to the substituent group. Okay, so let's number it in a way that this substituent group will receive the lowest possible number of carbon atom. So let's start from here. 1, 2, 3, 4, 5, 6, 7. Okay, let's also name this side. 1, 2, 3, 4, 5, 6, 7. Now, if I follow this numbering, this side, this chlorine will be at the 3rd carbon atom, and this very chlorine also will be at the 5th carbon atom. But if I follow this numbering, this one will now be at the 3rd carbon atom, and this chlorine will now be at the 5th carbon atom. It means that any side I follow, chlorine will still maintain 3 and 5. Okay, then for for methyl, methyl will still maintain 4. Okay, so methyl will still be at the 4th carbon atom. So that means that I am free to choose any side. So let me just choose this side, the first side. 1, 2, 3, 4, 5, 6, 7. Okay, I have finished numbering the carbon atoms in a way that the substituent group will receive the lowest possible number of carbon atoms. Then, if a particular substituent group is present more than once, the number of the substituent group is indicated by a prefix di if it is 2, tri if it is 3, tetra if it is 4, etc. attached to it. Okay, so it means that since we have 2 chlorine atoms here, we will say di. We will use di for this chlorine. That means dichloro. So we will now have here dichloro. So we have 3, 5 dichloro for the chlorine, since we have 2 chlorine atoms. Now the 5th one, if there is more than one type of substituent in a molecule, the substituents are named according to the alphabetical order. But where there are mixed substituents, the inorganic are named first. Okay, so here we have chlorine, and chlorine is an inorganic substituent. And we have methyl. Methyl is an organic substituent. So that means that we are going to name chlorine first because it's an inorganic substituent. Okay, so we are going to name chlorine first. So now let's actually name the compound. So the compound will now be 3, 5 dichloro 4 methyl heptane. Okay, so this is how to name this compound: 3, 5 dichloro 4 methyl heptane. So that is the name of this compound. Okay, let's see how we can name this compound. Now the first thing we are going to do is to recognize the parent chain. That is the chain with the longest continuous carbon atom. So let's count: 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So it means either we follow this chain or we follow this chain. So anyone can go. But let's take this straight one. So if we are taking this straight one, it now means that this particular molecule, methyl, is now an attachment molecule. Okay. Now let's recognize the presence of the substituent groups we have here. We have bromine here, we have bromine here, then we have methyl. Okay, now let's number the carbon atoms. So we are going to number it from the ends that will give the lowest possible number to these substituent groups. Okay, so let's number from this end: 1, 2, 3, 4, 5, 6, 7. Okay, let's number from this end: 1, 2, 3, 4, 5, 6, 7. Okay, let's start from this end. If you watch very well, you will see that from this end, methyl is at the second carbon atom, and this very bromine is at the third carbon atom, and this particular bromine is at the fifth carbon atom. But when we take our readings from this end, that's from this carbon atom going this way, then this very bromine will now be at the third carbon atom, and this particular bromine will be at the fifth carbon atom. Now methyl will be at the sixth carbon atom. So if you watch very well, we are going to have almost the same numbers for bromine. Over here, bromine is 3 when we are coming from this end. And over here, bromine is 5 when we are coming from this end. But when we are following this end, bromine will now be 3. And this particular bromine will now be 5. So the number for bromine is still the same thing. But the number that now change is for methyl. Methyl, if you follow this direction, methyl will be at the 6th carbon atom. But if you follow this direction, methyl will be at the 2nd carbon atom. So because of that, the best option is to follow this direction, to follow like this. So we are going to number from this end so that methyl will now be at the lowest carbon atom, which is 2. Okay, now that is the first one. We have made our decision on the end to follow. Now the next thing we are going to do is to recognize the organic and the inorganic substituents. The inorganic substituent we have here is bromine, and the organic is methyl. Then according to the rule says that we should name the inorganic substituent first before the organic. So we are going to name bromine first before methyl. Okay, now this since we have 7 carbon atoms here, it is going to be heptane. Then since we have heptane, then how many bromine atoms do we have? We have 2, so it is going to be dibromo. So it's going to be dibromo. Now that is because we have 2 atoms of bromine. Then we now have methyl. And this bromine is at, we are following this end. So the bromine is at 3 and 5. So it is at 3 and 5. Now let's name the compound. The compound is going to be 3,5-di 3,5-dibromo. Our methyl is at 6. It's at 6 carbon atoms, so it's going to be 3,5-dibromo. 6 methyl heptane. Okay, that is for this compound. So the name of this compound is 3,5-dibromo 6-methyl-heptane. Okay, let's look at how to name this very compound. Now in this very compound we have let's recognize the parent chain. 1, 2, 3, 4, 5. That is for this one. Then let's follow this side and count. We have 1, 2, 3. In this place we have 3 carbon atoms. So that means 3 plus this 3 is 6. So our parent chain is going to go like this. So our parent chain is going like this. So automatically means that this particular one and this one, they are the substituents we are having in this compound. Okay, now since we are following this direction, this chain is now going to be hexane. 1, 2, 3, 4, 5, 6. So it is hexane. That's the one with 6 carbon atoms. Okay, now the substituents are found at where? Let's name it. We are going to have 1, 2, 3, and here we will be having 4, 5, 6 because we have 3 carbon atoms here. Now the substituents are at the second one and the third one. So in the second one we have chloro, so it is 2 chloro. Then at the third carbon atom we have ethyl. We have ethyl, so we have 3 ethyl. Okay, so let's see how we can now name this compound. We are going to start from the inorganic, which is the chlorine. So we will say 2 chloro. So we'll say 2 chloro, 3 ethyl hexane. Okay, that is the name of this very compound. 2 chloro, 3 ethyl hexane. So when you see this very a compound like this, you need to be very careful. You need to check the number of carbon atoms that is in this side. So you don't always look at the straight one. You don't always look at the straight one. So you check this other side to see if the number of carbon atom there is longer than this other one before you make your decision to select your parent chain. Okay, now let's see how we can name compounds with double bond and triple bond. Okay, now like this one, the first thing we will do is to count the number of carbon atoms we have in the molecule. So let's count it. 1, 2, 3, 4, 5. Now this 5 from alkane is pentane. Okay, is pentane. But because we have double bond, it's no longer pentane. It is now pentene. Now the double bond means that this compound is an alkene. So which is pentene. Now we need to recognize the particular carbon atom where this double bond is. And this double bond is at the second carbon atom if we count from this end. If we count from this end, yes, and we cannot count from this end. It is from this end that we count, which is 1, 2, 3, 4, 5. Okay, now because the double bond is at the second carbon atom, now what we will do is we will write this thing. Instead of us to say pentene, we will say pent. We will stop. Now from this place we have in, that is where we put the position of the double bond. We will now put 2 then before that in. So the correct name of this compound is pentoin. Okay, that is how to name a compound with a double bond. Try to name these compounds. Now let's look at how we can name this very compound. Now over here we have how many carbon atoms? 1, 2, 3, 4, 5, 6. So this is hexane, but we have double bond, so it is no longer hexane, it is now hexene. Now this hexene is at what carbon atom? 1, 2, 3, 4, 5, 6. It is at second carbon atom. So the double bond is at the second carbon atom. Now this double bond is a functional group, but we have a substituent group here, and according to our rule said that we should number from the end that will favor the functional group, even if we have a particular substituent group. So this time around, the functional group is the group that will help us to number. So we are numbering in a way that will favor the functional group, okay, that will make the functional group to have the lowest or smallest possible number of carbon atom. Okay, so it is this end that we will name and not from this end. So now the substituent group we have here is chlorine, and this chlorine is 2. Then our rules say that if we have more than one substituent group, we should indicate the number by putting the light of di, tri, tetra. Now di is when it is 2, tri is when it is 3, then tetra is when it is 4. Now since we have two atoms of chlorine, we are going to use the prefix di. So it is going to be dichloro. Okay, so we have dichloro, and this dichloro is at 3 and 4. So it is 3, 4 dichloro. Hexene. But this hexene, we are identifying where the double bond is. Double bond is at the second carbon atom. So now let's see how we can now name this compound properly. So this compound is going to name as 3, 4 dichloro hex 2 in. Okay, so this is 3,4 dichloro hex 2 in.